Hello, in this video we're going to take a look at synthetic division to divide polynomials. And synthetic division, the way we're going to look at it, will only work if our divisor, what we're dividing by, what's in the denominator or what's on the outside of our division, is in the form of x plus or minus a constant. So for the example that we have here, we're going to divide 6x to the 6th minus 9x to the 4th plus 9x squared plus 2 divided by x minus 2. And that x minus 2 has to be x plus or minus a constant in order to do division using synthetic division. If that's anything else, then polynomial long division is the approach that you most likely want to take. Alright, so when we're setting this up, we always want to make sure that we're not missing any terms. So here we have 6x to the 6th minus 9x to the 4th. We're missing an x to the 5th term. So we want to make sure that we rewrite that divisor and we put in 0 coefficients for any of the powers of x that don't appear in that polynomial. And so we have 6x to the 6th minus 9x to the 4th. We're missing our x cubed term as well, so we're going to add in 0 x cubes and then plus 9x squared. We're missing an x term, so we're going to add in 0x, and then we've got our plus 2. Those zeros are very important, and it's going to make a big difference in our answer if we were to leave them out. So we want to make sure that we have 0 factors for any of those missing terms. All right, to set up our synthetic division, what we're going to do is we're going to take whatever our x plus or minus our constant, our divisor here, we're going to take that constant number and we are going to change the sign. In this case, we've got x minus 2, so we're going to write a positive 2 over here. And the reason for that is we want to add instead of subtract. All right, now we are going to look at just the coefficients for our dividend, our numerator, and write them underneath our house. So we've got 6, 0, negative 9, 0, 9, 0, and 2. That first coefficient, the 6, our leading coefficient, is always going to come straight down. And then we are going to multiply our number out front by the number on the bottom and write it in the next blank. So 2 times 6 is 12. And then going down, we're going to add. So 0 plus 12 is 12. 2 times 12 is 24. Negative 9 plus 24, and we're just going to keep repeating this process until we get to the end. So negative 9 plus 24 is going to be 15 times 2 is 30. 0 plus 30 is 30 times 2 is 60 plus 9 gives us 69 times 2 is 138 plus 0 is 138. 2 times 138 is 276 plus 2 gives us 278. All right, the numbers down at the bottom are going to represent our quotient and our remainder. So the very last number at the end, that is our remainder. So our remainder here is going to be 278. And then what's left is going to be our coefficient. So we're going to go the exact opposite direction from what we did when we set up the numbers on the top row, we're going to go backwards. The first number next to our remainder is going to be our constant, and then our x term, our x squared term, x cubed term, x to the fourth, and x to the fifth. It will always be whatever our degree is here divided by whatever our degree is here. So x to the sixth divided by x is going to be an x to the fifth. And so our quotient is made up of those coefficients. That's going to be our polynomial at the bottom, 6x to the fifth plus 12x to the fourth plus 15x cubed plus 30x squared plus 69x plus 138 is our quotient, and our remainder is 278. Sometimes you'll list them out separately, and then sometimes you might write it where it's your quotient plus your remainder divided by that divisor. So just pay attention to how the instructions on the problem are asking you to write your answer, whether you're giving your quotient and your remainder or whether you're just doing that division. All right, our next example, we've got synthetic division. Use synthetic division to determine if x minus 1 is a factor of the polynomial 12x cubed minus 16x squared minus 11x plus 68. Remember, we use the term factor, meaning that it goes evenly into it, or it has a remainder of 0. And so that's how we're going to determine this. We are going to do the same division just like we did on the previous example. And if our remainder is equal to 0, then the answer is yes, it's a factor. If our remainder is anything else, then it is not a factor. So we're going to divide x minus 1. So that means we're going to change the sign on that minus 1 and write it as a positive 1. And then for our dividend, we want to make sure we're not missing any terms. If so, we'll add in zeros just like we did on the last one. We've got x cubed, x squared, x to the first, and our constant. We're not missing anything, and they're already in order, so we're just going to write our coefficients. Our 12 comes straight down. 1 times 12 is 12. Negative 16 plus 12 is negative 4. Negative 11 and negative 4 is negative 15. And then 68 minus 15 is 53. So our remainder here is going to be 53. So since this is not 0, then that means that x minus 1 is not a factor of our polynomial. All right, we're going to do the exact same thing to determine if x minus 4 is a factor of 2x to the fourth minus 8x cubed minus 6x plus 24. So again, we're going to change our sign. X minus 4 is going to give us a positive 4. And then our coefficients are 2, negative 8, negative 6, and 24. That 2 is going to come straight down. 4 times 2 is 8. Negative 8 plus 8 is 0. 4 times 0 is 0. Negative 6 plus 0 is negative 6, and 4 times negative 6 is negative 24. 24 and negative 24 gives us 0. That last number is our remainder. So since this is 0, that means x minus 4 is a factor. All right, I'll see you guys next time.